When n is not too high, we can find the binomial coefficients using Pascal's triangle. But when n is large, we have to find an alternative way of finding the binomial coefficients. And one such method is using combinations. So a combination is an arrangement of objects in which there is no specific order. To understand this, let's look closely at the expansion of a plus b to the power of 4. Now, a plus b to the power of 4 means that you're multiplying a plus b by itself 4 times. So you have a plus b multiplied by a plus b multiplied by a plus b multiplied by a plus b. Now, the question here is, how many ways are there of getting a to the power of 4? We can get a to the power of 4 by multiplying a by a by a. Okay, so there's only one way of getting a to the power of 4, and that will be a multiplied by a multiplied by a multiplied by a. So we have one way. How about if we want to find a cubed b? That will mean that we have to multiply a by a, and then by a in the third bracket, and then by b in the fourth bracket. So that means one way of getting a cubed b will be a multiplied by a multiplied by a multiplied by b. Another way could be a multiplied by a, and then multiplied by b multiplied by a. So in the third bracket, instead of multiplying by a, you multiply by b. Okay. Another way could be a multiplied by b multiplied by a multiplied by a. Another way could be b multiplied by a multiplied by a multiplied by a. And those are 4 different ways of getting a cubed b. Ways of getting a squared b squared could be a multiplied by a multiplied by b multiplied by b. Another way could be a multiplied by b multiplied by a multiplied by b. Another way could be a multiplied by b multiplied by b multiplied by a. Another way could be b multiplied by b multiplied by a multiplied by a. Another way could be b multiplied by a multiplied by b multiplied by a. Another way could be b multiplied by a multiplied by a multiplied by b. And these are 6 different ways of getting a squared b squared. Ways of getting a b cubed. One way could be a by b by b by b. Another way could be b multiplied by a multiplied by b multiplied by b. Another way could be b multiplied by b multiplied by a multiplied by b. Another way could be b multiplied by b multiplied by b multiplied by a. So those are 4 ways. And ways of getting b to the power 4, it's just one, which will be b by b by b and by b. So we have one way. Now, there has to be a way on how you can communicate this mathematically to make it clearer to the person who's reading what you're trying to say. So mathematically, there's a way that we write this, and I'm going to show you in the next page. So the situation where no b's are chosen from any of the 4 brackets. Okay, so remember, no b's are chosen, okay, from any of those 4 brackets, can be written as 4 choose 0 or just 4 0. Okay, so which means in this case, first column, we are not choosing any base. We can write this as 4 choose 0 because you're not choosing any base. Now, the situation where 1b can be chosen from any of the four brackets is written as 4 choose 1 or 4 1. So, which means here, the second column, we can write this as, because 1b is being chosen here, so 4 1. And likewise, in the third column, 2b's are chosen, 4 choose 2, 3b's are chosen, 4 choose 3, 4b's are chosen, 4 choose 4. Now, if you look at these numbers here, 1, 4, 6, 4, 1, they correspond to the fifth row of Pascal's triangle. Okay? So basically, these numbers here correspond to this one, and this one likewise. They correspond to fifth row of Pascal's triangle. And which means the expansion of a plus b to the power of 4, this expansion here, can be written as this, okay? 40 a to the power 4, 41 a cubed b plus 42 a squared b squared plus 43 a b cubed plus 44 b to the power 4. Now remember, here we are actually focusing on the coefficients. So these coefficients 1, 4, 6, 4, 1 can be represented as combinations. Okay, so 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. And we have seen from our investigation that 4 choose 0 is 1, 4 choose 1 is 4, 4 choose 2 is 6, 4 choose 3, because the number of ways of choosing 0b's is 1, 1b is 4, 2b's is 6 from the four brackets. Okay, and if you simplify this, it should be able to give you that as your solution. So the next section that I want us to look at is how to work out these combinations. Okay, how do we work out something like 4 choose 3, 4 choose 2? There is a way, there is a formula. Now, the number of ways to choose R objects from a group of N objects is written as N choose R. And N choose R is equal to N factorial over R factorial multiplied by N minus R factorial. Now, and I'm going to show you here how to work out those combinations. So, first of all, the factorial guy. What does 4 factorial mean? 4 factorial means you multiply 4 by 3 by 2 by 1. Okay? And that will be equal to 24. So basically, the word factorial means to multiply a series of descending natural numbers. N factorial is the same as n multiplied by n minus 1 multiplied by n minus 2 multiplied by n minus 3. And remember, we said descending natural numbers. So this goes on and on up to 3, 2, and 1. Okay? You can simplify expressions like these ones here. 9 factorial divided by 6 factorial. That will be equal to, let me write it this way. It's easier to read it in that form. And this will be equal to 9 multiplied by 8, 7 multiplied by 6 factorial over 6 factorial. Those two cancel, so you remain with 9 multiplied by 8 multiplied by 7, which will be 504. We can also simplify expressions like these ones here, and this will be equal to n multiplied by n minus 1 multiplied by n minus 2 multiplied by n minus 3 factorial over n minus 3 factorial. This cancel, So this will be equal to n into n minus 1 into n minus 2. Now, back to binomial coefficients. Now, the binomial coefficient below, 8 choose 3, corresponds to the number of ways of choosing 3 b's from the 8 brackets in the expansion of a plus b to the power of 8. Now, what we want to find out is, we want to see if the formula, this formula here, remember we said nr is equal to n factorial over r factorial into n minus r factorial. So we want to see if this formula works in finding the binomial coefficients. So 8 choose 3 using this formula will be equal to, so this will be equal to 8 factorial over 3 factorial multiplied by 8 minus 3 factorial. And this will be equal to 8 factorial over 3 factorial multiplied by 5 factorial, which will be equal to, we can expand 8 factorial this way, so that will be 8 multiplied by 7 multiplied by 6 multiplied by 5 factorial over 3 factorial is just 3 multiplied by 2 multiplied by 1. 5 factorial, we can just leave it as 5 factorial because these two cancel. So, and 3 multiplied by 2 is 6. So again, these two cancel. So what we'll be left with is 8 multiplied by 7, which is just 56. So, but how do we know if this combination is correct? We can go back to Pascal's triangle and check, because we said that the binomial coefficients that you get from combinations, they should be the same as the coefficient that you get from Pascal's triangle. So if you go to Pascal's triangle, and this will be this row here, which is the 8th row, you can see that 8 choose 0 is this one, 8 choose 1 is this one, 8 choose 2, 8 choose 3, and you can see that 8 choose 3 is actually 56. Okay, and this goes on up to 8 choose 8, but this is what we wanted. We can see that 8 choose 3 is actually 56. So if we go back, we can confirm that actually this binomial coefficient that we get from combinations, they're the same as what we get from Pascal's triangle. Okay, in the next question, the binomial coefficient below corresponds to the number of ways of choosing 7 b's from the 9 brackets in the expansion of a plus b to the power of 9. Let's see if the formula works. And the formula for binomial coefficients is n choose r is equals to n factorial over r factorial multiplied by n minus r factorial. So we can use that formula to simplify this coefficient here. And this coefficient will be equal to 9 factorial over 7 factorial multiplied by 9 minus 7 factorial, which will be equal to 9 factorial over 7 factorial multiplied by 2 factorial, and that will be equal to 9 multiplied by 8 multiplied by 7, and we can actually stop there at 7 factorial over 7 factorial multiplied by 2 multiplied by 1. 2 factorial is just 2. Anyway, So these two cancel, and what we'll be left with is 72 divided by 2, which is 36. And which means that 9 choose 7 is equal to 36. We can confirm that from the Pascal's triangle again. Now, if you look at the Pascal's triangle, we can be able to see that, and this will be on the 9th row. This will be 9 choose 0, 9 choose 1, 9 choose 2, 9 choose 3, 9 choose 4, 9 choose 5, 9 choose 6, and 9 choose 7. And we can see that 9 choose 7 is equal to 36. So we can go back to our question and confirm that actually 9 choose 7 is equal to 36, because it's the same binomial coefficient if you compare with the Pascal's triangle.